Hi, I'm going to talk very briefly about some value range tracking work that's both has already happened, is kind of in progress, and then some possible future directions. I've kind of invented some terminology because, as far as I know, in the literature, no terminology exists for the different sort of kinds of value range tracking that I've observed existing. So right now in NIR we have a few instances of what I call zeroth order range tracking, where we sort of implicitly take knowledge that we have about the kinds of values that can be produced by an operation and then use that to delete some code. So in this example, we know that B to F is only going to generate values 0 and 1, so doing an absolute value on that is completely useless, so we can just delete that operation. And there's maybe half a dozen or so other cases that are similar to that already exist in NIR opt algebraic. So I've done some work sort of building from that into a more general framework to implement what I would call first order tracking, where you can ask questions about a particular SSA value and it works back through how that SSA value was created and sort of infers things from what you know about those operations. So if you see an absolute value on some SSA value to produce another SSA value, you know that the result must be greater than or equal to 0. So we can track knowledge about relationship to 0 and then employ that knowledge to do other optimizations. So for example, we can eliminate tautological or contradictory comparisons, like the example here. If we're comparing something that is definitely not negative with something that is definitely not positive, well, we know that must always evaluate out to true, so we can just delete it. So far this has had pretty good results. I've implemented a handful of optimizations based on this, but the two that were kind of the biggest bang for the buck were deleting useless comparisons and converting some fmin operators to fsat operators, and it helps a whole big pile of shaders. The only reason this hasn't already gone out for review on the list is you see there's 2 shaders that were hurt for instructions, and there were a few shaders that were hurt for cycles because our scheduler does some kind of dumb things and we end up with a bunch of spills in some cases, and so there's a few shaders that just fall off a cliff. So there's some existing second order tracking that has already recently landed in Mesa. Tim Arceri did some work where if you have a Boolean condition in an if conditional, you can sort of push down into the then and else branches of that if statement that you know if you see that Boolean condition again in the then branch, you know it's true, so you can just replace it with true. And likewise in the else branch, you can replace it with false. So you're kind of pushing knowledge from flow control about values down. We can do similar kinds of things to that to help the algebraic optimizations. Also, there's a handful of different ways that we can do that. One that seems attractive is to basically add things that look like Clang's assume operator, so we can sort of create a new SSA value from an old SSA value, but add some knowledge about range of values that it can have. That has the advantage of, after we flatten out if statements into like conditional selects, we still know things about the flow controlled and data flowed SSA values. It has the disadvantage that it causes problems with CSE and copy propagation. So there may be some trade-offs and some other ways that we could do that. Perhaps instead of hashing just based on the SSA value, combine the SSA value and the block ID, or do some combination of the two at different levels. So some of the code is currently available at my CGit. I'm old, so I haven't converted over to GitLab yet. Maybe one of these days. And that's it.